Good morning, children of class 8th. Today we are going to see the second video or the second part of the fourth chapter in chemistry. And this is about atomic structure. Last time we saw in the atomic structure about the three subatomic particles which were protons, electrons and neutrons. Today we will see how the subatomic particles are arranged in the atom. Now this possibly could not be in your course, but still, because it's given in the book, I will be explaining these topics to you. The first one is the Plum pudding model that was proposed by J.J. Thomson. As the name suggests, plum pudding model, you know what pudding is? Pudding is kheer. And the plums are the dry fruits that are put in the kheer. So, J.J. Thomson explained how the protons and electrons are arranged in an atom in the plum pudding model. So he discovered the electrons earlier, we know, and he gave the plum pudding theory to show the arrangement of various subatomic particles. In this model, he considered atom to be a sphere of positive charge. As we can see here, positive charges, these positive charges, they represent protons which are present in an atom. And we see that he also told that there were negative charges which were equivalent in number to the positive charges inside the atom. So we see that these protons or the positive charges, they are equal to the electrons or the negative charges in an atom. And we see here that the positive charges, they represent the pudding. The positive charges, they represent the pudding or the kheer in an atom. And the negative charges, they are like the plum, or they are like the dry fruits in the pudding, as you see. As the positive charges on the sphere are equal to the negative charges in an atom, the atom as a result remains neutral. Now let us also study an experiment that was performed by Rutherford. And Rutherford performed an experiment with the gold foil. This experiment is also called the scattering experiment because he scattered alpha particles. Now we will see that how this experiment was performed by Rutherford. Rutherford, he took a very thin gold foil. If we see through an electron microscope, we see that this area represents the thin gold foil. And he bombarded alpha particles. Do you see, children, here? Alpha particles or positively charged particles. So he bombarded this gold foil with alpha particles, and these alpha particles he released from a radioactive polonium. Polonium is one of the elements found in the periodic table. These are radioactive, and he made these alpha particles to pass through the gold foil, which is shown here, and he made these alpha particles to strike or hit a zinc sulfide screen. This black line here I want to represent as a zinc sulfide screen. Now, what conclusion or inference did Rutherford draw from his experiment? Firstly, he observed that most of the alpha particles, they pass straight through. They pass straight through. Do you see here? All these arrows, these lines are passing straight through the gold foil and hitting the zinc sulfide screen. So maximum or most of the alpha particles, they passed in straight lines through the gold foil. They passed through straight lines. Then he concluded that most of the space in the atom, these are atoms, so most of the space in between these atoms is empty. This is what he concluded. Then his second observation was that very few alpha particles, if you see here, this one, very few alpha particles were deflected through an angle. Do we see here that these alpha particles, they have deflected through an angle? As alpha particles are positively charged and they hit the positively charged nucleus inside the atoms, so the alpha particles were deflected and they hit the zinc sulfide screen. So he concluded that the nucleus of an atom is positively charged. Do you see that in the gold foil atoms here, children? That the nucleus of these atoms is positively charged, which repelled at an angle the alpha particles. Thirdly, he observed that there were extremely few, maybe 2 or 3. You see here, these rays show that the alpha particle is returning back on its pathway. So he observed that extremely few particles retraced or they returned back on the same path. Thus he concluded that nucleus is hard and dense. Now, let us see some interesting facts which you must remember and memorize. Today, we can split or break an atom. In past times, it was believed that atom could not be divided further, but today we can see that atom can be split further. The second thing, children, which you must memorize and remember is that atom can be split by using a special machine. Now this machine is called particle accelerator. This machine is utilized to split the atom in a special way. Then the third thing, which is an important fact, is atoms are split into protons, electrons and neutrons, which are the 3 subatomic particles found inside atoms. Electrons are subatomic particles which belong to family of leptons. Children, remember this one, important for the exam. Electrons are subatomic particles which belong to the family of leptons, which cannot be split further. Then let us see the fifth fact. Other subatomic particles like neutrons and protons, they are present in the nucleus and these can be split up. These particles can be split up. Let me highlight this. These particles, which particles, children? The neutrons and the protons. These can be split up inside the nucleus into smaller particles called quarks. Now, let us look at the concept of atomic number and mass number, which you will be using in chemistry in this class and in many more classes that will come after. Now, what is atomic number? Atomic number is represented by a symbol Z. Do you see this symbol Z? So atomic number is represented by the symbol Z. Let us remember that. And mass number, I will speak about what atomic number and mass numbers is. But here, mass number is represented by the symbol A. Keep that in mind, children. Atomic number. How can we define or explain atomic number? Atomic number is numerically equal to the number of protons present in the nucleus of an atom. We all know that atom has got a nucleus, and outside the atom has got these shells outside. This is the nucleus. So the protons, let me give the symbol small p to proton. The number of protons present in the nucleus of an atom, they are the atomic number. So atomic number Z is equal to the number of protons that are present in the nucleus. Now we see that there are electrons that are present in the shells outside the nucleus in an atom. Now Z, or the atomic number, is also equal to the number of electrons. So we can say that atomic number Z is either equal to the number of protons or the number of electrons in an atom, a neutral atom. Now let us pay attention to what atomic mass is. Atomic mass can be defined as is the mass or the weight of an atom, which is the number of protons and neutrons present in the nucleus. Atomic mass is represented by the symbol A. Do you see this, children? This is the symbol A. As we talked earlier, the atomic mass is represented by symbol A. And this symbol A, or the atomic mass, is equal to the number of protons plus the number of neutrons, represented by small n, inside the nucleus of an atom. So what is atomic mass A? Atomic mass A is equal to the number of protons plus the number of neutrons that are present in the nucleus of an atom. So today we have learned up till here about these facts, and we will learn next time about the calculation of these entities, how we calculate the number of neutrons, the number of protons, etc. This we will see in the next video. Till then, I wish you all the best. Have a good day. Thank you.